Alright, welcome back, bettors. This is Mitch with bettor-picks. Sorry that I haven't made a video in a while. I've been really busy, especially with the holiday season, but finally back here. So let's just jump right into it. Last time we talked about the single variable case for a regression. If you're trying to predict the number of points a team is going to score, it doesn't only depend on the amount of rushing yards, right? It kind of depends on a bunch of different things. So many things you probably won't be able to get everything. But we're going to look at a way to start looking at multiple variables, and it's called multivariate regression. Without going more into it today, we're just going to focus on looking at the data, right? We have the team name, and this is all available on the website, and I'll put a link in the description as well. But we have the points the team scored, the opponent they played, how much the opponent scored, and then we're going to look at specifically in this video, we're going to look at not only rushing yards this time, but we're going to also look at passing yards and the number of turnovers that this team got. So again, everything with the word opponent means that that's what the opponent did. So in this top example, the opponent is the Lions. So anytime it says the opponent, so this means that the Lions had 361 passing yards and 116 rushing yards, right? And the same with the opponent. So what we're going to do is we're going to examine how passing yards, rushing yards, and turnovers affects points, and we're going to see and potentially talk more about the statistics that are involved. So what we're going to need to do is we're going to need the points. We'll need the I'm going to do command passing yards and rushing yards and turnovers. And we don't really need the team name yet. It's easier to not keep it in. If you want to, you can, just to view it easier, but really we're trying to predict points based on passing yards, rushing yards, and turnovers, right? And again, this isn't a perfect example because obviously if you know the number of passing yards and rushing yards in a game, like, you can get a pretty good guess of the points. So it's not going to be good to like predict what's going to happen in the future, but this is a good way to start attributing what's important and start understanding how prediction actually works and how you can start playing around with numbers and the correlations behind them. So I'm just going to copy all those, and I'm going to command N, start a new page, and I'm just going to paste it all in. So now we have all the data we have, and one important thing that you don't necessarily need in Python, but you will for Excel, you can see these blanks here, and so we're just going to need to figure out how to fill in the blanks with 0. Bin turnovers here, and I do equals if. I can use the if statement. So if this is a blank cell, then make it 0. If not, make it this. Right. And then hopefully if I drag this all the way down, it should fill in the blanks with 0. Let's see. Alright, it seems like it worked. And so then what I'm going to do is I'm going to command shift down, copy this, and we're just going to paste special, and you just want the values. Okay. And I'm going to take these two guys and I'll delete them. And now we have just the values. So again, when it's blanks, it just means those are 0 turnovers. So then what I'm going to do is I'm going to save this as something else. So we're just going to call it multi. I'm just going to call it multi. And then now what we're going to do is, remember we added the data analysis tool pack. So we can go to data, and it's right here. And so we're going to go to the same thing we did as last time. So we're going to go to regression, and we're going to input our y range. So y, again, right, like if you think of, remember the equation for middle school, guys, y equals mx plus b. Y is the variable you're trying to predict. So we're trying to predict points. So what we're going to do is we're going to take all the values and points. So, and then what we're going to also need now, remember last time we did a single column for the x variables, which means the variables you want to predict with. Now what we're going to do is we're going to use all 3 of those columns and command shift down for everything. And that is now our x. Again, we have the labels. I'm not going to include confidence interval or constant 0. We're going to put it in just on this page. That's fine. And I actually will plot out the line fits just so we can get into a discussion of why this is actually pretty solid. We won't go over the residuals because I talked about that last time. Okay, it's going to take a second. It's going to spit everything out. Okay, so what we are going to do is we're going to look at the, before we get into all this, let's look at some of these plots. So the first one we'll look at is the rushing yards, which is what we looked at last time. Let's make this bigger. I don't want to see predicted points, honestly. Delete those. There we go. So basically, this is just showing a plot of, okay, well, the number of points you get based on the number of rushing yards, right? So clearly, it looks like the more rushing yards you get, the more points you score, but it's obviously pretty random. And again, remember last time what we did was we found the equation that's just this line, right? The problem is when we just look at one variable, we're only establishing a relationship between points and rushing yards, when in reality, that's not the only thing that affects points. There's a lot more, including the number of turnovers you have and including the number of passing yards you have. So when we're doing a single variable regression, it kind of just shows, one specific variable. But when we add multiple variables, that is actually starting to get a little more, A, it's getting a little more real, and B, it's actually controlling for, relationships between variables. When you start taking these other variables into account, it helps the statistics behind it to find those correlations between everything so that it can associate the correct values, right? So a good example is like, if you're trying to predict like somebody's weight based on their height, right? Like however tall you are, it definitely does impact how much you weigh, but at the same time, there's so many other things that attribute to how much you weigh, right? If you only looked at height, you're not going to be nearly as accurate as if you looked at height and you looked at genetics and you looked at, the diet that someone has and the exercise amount, right? It's going to be different depending on people's heights. The same thing here, right? The points is going to be different based on, yes, rushing yards has an impact, but it's not the only thing. And if you don't have more variables, you're not going to get the correct attribution there. So we can look at the passing yards as well. I'm just going to delete these since we're not going to actually use them. So let's look at passing yards, and we'll make it bigger. And I'll delete the predicted points. And again, you can see this is almost maybe a little more positive in terms of, the more passing yards you have, the more points you get, right? This kind of makes sense. And so the point of this is that now we're not just going to be looking at, okay, in isolation, this is passing yards and this is rushing yards. Now we want to say, okay, if we control for both passing yards and rushing yards, what actually happens? So let's delete that. And we can look at the turnovers as well just to get a good understanding. And this is going to be interesting, right? Because turnovers is a discrete number. It's not continuous, right? Like you can't get like 3.5 turnovers. So it looks like, right, it's pretty random. And interestingly enough, like, if you have 5 turnovers, you're hovering around here. And this time it's got 1 turnover, scored this many points, right? It's kind of random. We're going to look at the output of the model and actually see if that is has any impact. So I'll delete that. So now, if you recall, the most important parts are right here, the coefficients. I'll make these columns a little bigger so we can read them well. The coefficients are what's important. So now what we're looking at is, this is essentially an equation, right? It's now instead of y equals mx plus b, it's y equals m1x plus m2x plus m3x plus b, right? And I'll put a little graphic here to make that a little easier to understand. But basically, if you look at this, for example, like we have our observations. So I'll take the first point and I'll paste it right here. And so the predicted points on the first observation was 24, which is actually pretty close. That's not bad, right? And so what's actually happening in the stats in the background is that it's trying its best to use the data that we input. So it's trying to take these 3 variables and come up with a linear combination to make these things equal to 27. So 275 times something plus 112 times something plus 1 times something equals 27. And then it's trying to do that for every single variable and try to minimize the error, right? So it's trying to minimize the difference between 24 and 27 is 2.7, right? So it's trying to minimize these numbers. And what it's looking like is, so if I take these coefficients, this is essentially, this spits out the answer that minimizes these residuals the best in terms of an ordinary least squares approach, which is just a very common linear algebra solution for statistics. But basically, it's saying, I'm going to do a little formula here. If I take the number of passing yards, multiply that by this coefficient, which is 0.06, and I add that to the number of rushing yards times the coefficient, which is the rushing yards coefficient, 0.08, and I add that to the number of turnovers times the turnovers coefficient, and I finally add the intercept, then the answer becomes, anyone guess? Yep, it's going to be exactly the prediction, right? So this is essentially an equation, right? So this is a model in this sense. So now we're saying with this data set, if you give me a random game with passing yards, rushing yards, and the number of turnovers, I can give you a predicted number of points that team's going to score in that game, right? And then we can look up here, and these two numbers are important. Typically, you want to look at the adjusted R-squared. That's like the most realistic one, and it's 55% if you round up. So basically, it's saying that 55% of the variation in the number of points a team scored is described by these three variables, which is not that much, but it's also pretty solid and powerful to say, with three variables, 54% of the variation is explained. And again, it's nothing fantastic, right? Like, we can't use this to predict next week's because this kind of depends, right? This all happened within the game. So if you know how many passing yards and rushing yards and turnovers the team's going to have in a single game, then yes, you can predict the points, but you don't know these numbers going into a game, right? And that's what makes it kind of challenging and tough. And then when you actually get into modeling with actual prediction, you have to use a lot more variable and a lot more complex statistics to get any sort of edge out of that. But the coefficients here are important, right, because they actually are used for the model now. So now that you have you have the number of, so now you can essentially predict any number of points given these three variables. But then the other thing is you got to look at these three. They all kind of mean the same thing. All three of these values kind of tell the same story. They're saying, like, on average, how incorrect this is. The t-stat is like a number that's used to determine whether or not you can actually believe this number, and similar with the p-value. So in general, you want the standard error to be low, you want the t-stat to be high, and you want the p-value to be really low. So when you're looking at this, the p-value is 0.31, which is pretty high relative to what a p-value normally is. So you might look at this and say, okay, the intercept, you can't really believe it. And I mean, it makes a little bit of sense, but don't worry about that too much right now for the early introductions. Whereas pass yards and rushing yards, right, they're both 5.3 to the minus 12 and minus 8, which is essentially really, really tiny. It's almost zero. So when the p-value is really small, that essentially means that these are pretty, like, you can trust these to an extent. And then the turnovers actually it's small relative to all these other ones, so it's a little bit more believable than, some of these. So these things basically just mean, like, you can look at these and say, okay, pass yards and rushing yards are like, we can almost say that those definitely have an impact on, actually, you can't ever say, yes, these are true. Like in stats, you just can't say that, but you can reject the fact that they're not true. And then in a lot of stats classes and a lot of statistics work in general, like if you get a p-value this high, and typically you would say, we reject that this is the true coefficient. And then something that's this low, usually the cutoff is 5%, and this is sitting at about just under 2%. So it's kind of on the edge, depending on how you want to look at it, to reject or not reject. But I would go ahead and say that this is actually pretty important as well. Like, when you look at these coefficients, one of the more important things to think about is the direction of it. So clearly these are both positive numbers and turnovers are negative. So this is essentially saying the more pass yards you get, the more points you'll score. The more rushing yards you get, the more points you'll score. And it actually looks like from this, the combination of the two, that the rushing yards actually has a slightly higher impact on the points, which is an interesting insight. So this is where the money ball idea comes from, right? Like in baseball, they started modeling stuff like this, and slugging percentage matters more. And then the basketball with the Warriors and stuff, 3-pointers matter more. So maybe if you look at this and do some analytics, you can find something interesting. Like, in this simple model, rushing yards actually matter more than passing. You could also do is, we've only looked at 3 variables. There's a bunch more variables here. You can look at, how does the opponent's passing yards impact the number of points you score. If there's anything you guys specifically want to learn about, happy to make videos about it. Just let me know in the comments or message me on Instagram or send me an email. And yeah, with that being said, make sure to check out the website. We got all the results, and we post results here every week. If you're interested in getting the predictions early, go ahead and check out the Patreon page, and we do everything for free, obviously, so any donations are much appreciated, but definitely not expected. Alright guys, best of luck with all your bets, and hope you guys are having a good start to the holiday season. Alright.